Hey, this is Captain Herzon at Wooten High School Forensics, here to teach you how death investigators use changes in core body temperatures to estimate time of death. Um, this is part of the process of what's known as algor mortis. There are four stages of death once the heart stops beating. Okay, the first step is called pallor mortis, in which um, the skin of the body takes on a pale color because since the heart has stopped beating, blood is not being pumped to all parts of the body. The second um, a step of death is what's known as algor mortis. So within the first, excuse me, 12 hours, the body loses temperature after the first hour at a rate of 1.5 degrees um, Fahrenheit per hour. The third stage is known as livor mortis, in which, since the heart has stopped beating, blood will flow to the lowest possible point. Okay. Um, and then finally is rigor mortis, which stiffening of the muscles due to no more ATP production to pump out calcium ions out of the muscle cells. So they begin to constrict, um, obviously with the eyelids, so it may appear um, that the person is waking up, um, and their eyes are actually opening. And then this would be preceded by the neck, and rigor mortis would continue through contraction of the muscles of the arms and legs. So it's very possible that there would be shifting of the body during this time of rigor mortis, which totally disappears after 24 hours. Okay? So, but this time I just wanted to exemplify in this video of showing how death investigators use changes in the core body temperature to estimate the time of death. Now, one thing that needs to get noted is that the death investigators have to determine what the ambient temperature is, because whatever that ambient temperature is, that would have a profound effect at the rate of the of the body core temperature cooling. Okay, certainly, if this was in a very frigid environment in which the temperatures would be close to 0 degrees, there would be a great difference of cooling of the body compared to if the temperatures were, say, 90 degrees and above. Okay? But for all practical purposes, we're just going to be using a standard experimental setup in which we can control and maintain the temperature to somewhat around um, room temperature, like 70 degrees or 72 degrees Fahrenheit. Okay? All right. So I actually do want to use a real example of a death scene and to show you how it's possible to do this calculation. So I'm going to use a pretty famous case, death investigation case. On January 28th of this year, you and your forensics team are dispatched to Calabasas, California, to the site of a helicopter crash, which took the life of former NBA star Kobe Bryant, his daughter, and 7 others. Fortunately, a group of top-notch agents, excuse me, like yourselves at Wooten High School, arrive at the scene. Your task, agents, is to estimate the time of death, noting that the current time that you did start the investigation is at 9 o'clock p.m. So first you have to write down the case number. And I'm going to use this as an example that most death investigations, and actually crime scenes and the collection of evidence, every item is is identified separately. So if you have something like a human body, there would be a case number relating to that piece of evidence. Okay, the body is evidence from the scene. So usually, um, law enforcement personnel, in order to maintain accurate records, they will identify the case starting off with the month of the year, and they can use a simple notation like J for January, okay, or JA, okay. So it's a little discriminate towards comparing to June and July, okay. And this would be the 28th day of January, in which this was case number 32. All right. And CB I just made up as like short for Calabasas. And for this scene, since there were 10 individuals who perished at the scene, 9 passengers and 1 pilot, on this we were looking at the first, the first individual. Okay, so at 9 p.m., the human remain core body temperature reads 92.6 degrees Fahrenheit. That's noted, and the team assembles at a nearby hangar to collect all the evidence and then start the calculation of the time of death. Incidentally, one of the tools that is used at the scene to take core body temperatures is one here by example from Arrowhead Forensics, a digital pocket-sized thermometer, a stainless steel, in which it could be inserted into the body to take the core body temperature. Okay, this also could be used for temperature of soils. Okay, for liquids. All right, but a different thermometer would be needed to take the ambient temperature. This one by Arrowhead Forensics runs at a price of around $52. Okay, so step one is really simple math. We've got our standard core body temperature of 98.6 degrees. And from that, we're going to subtract the core body temperature that was taken at 9 p.m., which was 92.6 degrees. So our temperature difference comes to 6 degrees Fahrenheit. Our second step, since our core body temperature at the scene was taken at 9 p.m., we use this analog clock to show you the process of estimating time of death, noting that we first need to reset the time to 1 hour earlier. That's because within the first hour, there is no to minimal changes in the body temperature. Okay, so we'll go ahead and do that. So now our time is set back for 8 p.m. Okay, now we do understand that after the first hour, the core body temperature decreases at a rate of 1.5 degrees per hour. Okay, and here the core body temperature dropped 6 degrees Fahrenheit. So after the first 2 hours, there's a 3-degree drop. So that takes us from 8 p.m. to 6 p.m. Okay, so we're halfway there. Another drop of 3 degrees would take us 2 more hours. Okay, so now it dials back to 4 o'clock p.m., which just happens to be our answer. So here, a drop of 6 degrees Fahrenheit is relative to the time of 4 o'clock p.m. in the afternoon. Okay. And this is really important to establish if the person actually died at impact of the crash site. So, what's really going to be important for investigators is to find off, like, for example, when the helicopter left the Bryant home on the grounds, the flight path it was taking, all right, and noting at the site of the crash at 9 o'clock p.m., what's the core body temperature. So this can help the investigators set up what's known as a timeline, okay, of when the flight originated to the time in which the core body temperatures were taken at the scene of the crash. Okay? So this is Captain Herzon. Hope you enjoyed this session of Algor Mortis. Till next time, have a great day.